All right, if you're taking AP Physics 1, you know freefall problems are everywhere. But what happens when a problem throws you a curveball and leaves out a super important piece of the puzzle? Today, we're going to crack a classic physics scenario: how to figure out an object's speed when you have no idea how long it's been falling.
Okay, let's picture this. It's a relatable and, let's be honest, pretty terrifying situation. You're up on a 10-meter balcony, you lean over and, oops, there goes your phone. Now, as it's plummeting towards the ground, the good physics student in you starts wondering, just how fast is that thing moving right before it completely shatters? Seems like a pretty standard problem, right? Well, kinda.
Because here's the twist. You know the height, sure, but you have absolutely no idea how long the fall took. You weren't timing it. And that, my friends, is the little trap that catches so many people off guard.
Yeah, let's call this what it is, the time trap. I mean, think about it. So many of the kinematic equations you've been memorizing, they all depend on t, right? On time. Without it, you can feel totally stuck, like there's just no way to get to the answer.
So that brings us to the big question. Is it even possible to find the final speed when all you have is the height? And the answer is absolutely 100% yes. You just need to know which tool to pull out of your physics toolbox.
And that very special tool is what I love to call the timeless equation. Seriously, this thing is your secret weapon for exactly these kinds of situations. It's this awesome formula that just completely gets around the need for time. And here it is in all its glory. V squared equals V naught squared plus 2a delta x. Now, I know it might look a little intense at first, but trust me, after today, this equation is going to be your new best friend. You can think of it like this. Every physics equation is like a key that opens a specific type of lock, right? Well, this one is the special, magic key for any problem where they give you the distance or the height, but they decide to keep the time a secret. So let's actually decode this thing piece by piece. Once you see what each of these variables actually stands for, you'll realize just how simple and, honestly, how powerful it is. First up, we've got v. This is just the final velocity. It's the speed of the object right at the end of its trip. For our poor phone, it's how fast it's going at the exact instant before it hits the pavement. This is the big prize, you know? It's the unknown we're solving for. Next, we have v0, or v naught. That's the initial velocity. And here is a huge tip for anyone in AP Physics. Look for the magic words dropped or from rest. Whenever you see that, it's a giant hint. It means the object wasn't thrown, it just started falling. So its initial velocity, v naught, is just 0, and that makes our lives so much easier. Then there's a for acceleration. For basically any free fall problem you'll see on Earth, this is a freebie. It's a gift. The acceleration from gravity is a constant, negative 9.8 meters per second squared. And that negative sign is super important. It just tells us that the acceleration is pointing down. And last but not least, delta x. That's just the displacement. In a problem like ours, it's the vertical distance it falls, the height of the balcony. And just like with acceleration, because the phone is moving downwards, we're going to make this number negative. Okay, enough theory. We've decoded the formula. We know what all the pieces mean. Now for the fun part, let's actually put it to work and solve that phone problem. It's time to figure out its final unfortunate speed. The best way to solve any physics problem is to have a game plan. Here's our simple 4-step strategy. First, we'll list everything we know. Second, we identify what we don't know, our target. Third, we plug all those numbers into our awesome timeless equation. And fourth, we just do the math and solve for the answer. Simple as that. Okay, let's go back to that balcony, 10 meters high. Phone's been dropped, no stopwatch. We've got our equation, we've got our strategy. Let's do this. Okay, steps 1 and 2. What do we know and what are we looking for? Well, we know the initial velocity, v naught, is 0 because it was dropped. We know acceleration, a, is gravity, so that's negative 9.8. And we know the displacement, delta x, is negative 10 meters because it's falling down. The only thing left is our unknown, the final velocity, v. Step 3, time to plug and chug. Our equation becomes v squared equals, 0 squared, which is just 0, plus 2 times negative 9.8 times negative 10. See how having that 0 for the initial velocity makes things really clean? And notice what happens when you multiply two negatives. You get a positive. So 2 times negative 9.8 times negative 10, that gives us a nice positive 196. So now we know that v squared is 196. We are so close, just one little step away from the answer.
All we have to do is take the square root of 196, which is 14. So the final velocity is negative 14 meters per second. The number 14, that's the speed. And that little negative sign, that just reminds us which direction it's going, down. And just like that, we did it. We found the speed, and we never even thought about time.
So what's the big deal here? Why does this all matter? Well, knowing which equation to grab isn't just about getting the right answer on a test. It's about having a strategic advantage. It's about being able to look at a problem and instantly see the quickest, most efficient way to solve it.
Just look at this side by side. On the left, you've got an equation that's perfect if you know the time. But on the right, you've got our new friend, the equation that's your hero when you know the distance. The real skill is learning to spot what information you're given because that tells you which tool to use.
So from now on, here's your mental checklist. When you see a free fall problem, just ask yourself these two questions. 1, does it give me a height or a distance? And 2, does it not give me the time? If you answer yes to both of those, boom, you know exactly which equation to pull out. This is your go-to.
You know, when you really think about it, what we just did was use physics to find a hidden connection between speed and distance, completely bypassing time. It really makes you wonder, doesn't it? What other hidden relationships are out there in the world just waiting for an equation to describe them? Thanks for joining me.